What's up guys, welcome back to my channel. In this video we will see together how we can work with MongoDB database on a Spring Boot project. So we will go through all the details from creating and preparing the working environment. We will be using Docker, and I will show you which UI tools that we can use to manipulate and access data on MongoDB. We will also create a CRUD endpoints and CRUD operations as basic. I will show you especially how you can integrate OpenApi within Spring Boot 3 and MongoDB, and a lot of more details like how to query data using the Mongo template, and also using DSL queries, and also using query methods, and so on and so forth. So the course is really detailed and contains all the details that you need to have a good start with MongoDB, and especially the most famous framework on the market today, Spring Boot. And now we talk about the Spring Boot 3, which is a kind of a new change comparing to the old versions. If you're new to my channel, just go ahead, subscribe to get notified about all the new videos that I'm publishing every week. Also, don't forget to take 1 second and smash the like button so I can keep continue on producing content like this for you guys. Thank you so much. And before we start, just want to remind you that you need to join the community that we are building. All the links are in the description below. Join us and be part of the greatest community that we are building right now. Don't forget to join the aliboucoding platform, where you can find many courses available there. So you will have all the courses and all the things that you need to become a good software developer. Thank you so much, and let's start our course. Before starting and diving into the technical part of this course, let's first answer the question, what is MongoDB? MongoDB is a free and open source cross-platform document-oriented database program. So MongoDB is a program which is a document-oriented database. Classified as a NoSQL or NoSQL database program, and MongoDB uses a JSON-like documents with optional schemas. We will explain this in a few seconds. MongoDB is developed by MongoDB Inc. Then, MongoDB is designed for scalability, high availability, and performance, with features such as automatic sharding and support for multi-document transactions. It is often used as the database component of the main stack, which is MongoDB Express, Angular, and Node. So in MongoDB, data is stored in flexible JSON-like documents. We call them BSON, which is binary JSON documents, that have a dynamic schema. So this means that you do not need to specify the structure of your data in advance, and you can change the structure of the data as your application evolves. Mongo also supports indexing, ad hoc queries, and aggregations. MongoDB is used in a wide range of applications, including modern web applications, data lake and data warehouse architectures, and mobile and IoT applications. Let's understand now the key differences between SQL and NoSQL databases. So the first one is the data model. This means that within SQL databases uses a structured tabular data model, where data is organized into rows and columns in tables. Meanwhile, NoSQL databases use a variety of data models, including document, key value, wide column, and graph. The second one is the schema. So SQL databases have a fixed schema, which means that the structure of the data must be defined in advance. From the other side, NoSQL databases have a flexible or dynamic schema, which means that the structure of the data can change over time. The next property is the ACID properties. ACID stands for atomicity, consistency, isolation, and durability. SQL databases support ACID properties which guarantee the transactions are processed reliably. With NoSQL databases may or may not support ACID properties depending on the specific database and the data model being used. Then we will talk about the query language. SQL databases use a standard query language called SQL, which is used to define and manipulate the data. The NoSQL databases may use SQL or a variety of other query languages depending on the specific database and data. And the last one is the use cases. So SQL databases are well suited for structured, transactional, and are often used in applications such as financial systems, HR, and e-commerce websites. The NoSQL databases are well suited for unstructured, large-scale data and are often used in applications such as real-time analytics, content management, and social networking. So these are the key differences between SQL and NoSQL databases. You may wonder when to choose between SQL databases and NoSQL databases. Now we will see the answer together. So when choosing between an SQL or structured query language database and NoSQL, by the way, NoSQL stands for not only SQL database, there are several factors to consider. Here are some steps that you can take to help make the decision. So first of all, try to define your requirements. Start by identifying the specific needs of your application and the type of data you will be working with. This will help you to narrow down your options and determine which type of database is best suited for your needs. Second step, consider the data model. This means you need to consider the structure of your data and how it will be stored and processed and accessed. If your data is structured and fits well into a tabular data model, and SQL database may be a good choice. If your data is unstructured, or if you need to store data in a variety of formats like text, images, audio, and so on and so forth, NoSQL databases may be a better fit for you. Third step, or the third option, you need to think about the schema. Determine whether you need a fixed schema where the structure of the data must be defined in advance, or a flexible or dynamic schema where the structure of the data can change over time. This will help you decide between an SQL databases which requires a fixed schema and a NoSQL database which supports flexible or dynamic schemas. The fourth step, evaluate the performance and scalability needs of your application. Consider the performance and scalability requirements of your application and whether an SQL or a NoSQL database is better suited to meet those needs. For example, NoSQL databases are often more scalable and performant than SQL databases, but may not support all of the features of an SQL database. This is really important factor to consider when you want to choose between SQL and NoSQL database. The last factor I want to talk about is considering the query language. If you are familiar with SQL, or if your team has experience with SQL databases, an SQL database may be a good choice. If you prefer a different language, or if you are building a new application and are open to learning a new query language, so a NoSQL database may be a better fit for you. To conclude this, Ultimately, the best choice will depend on the specific requirements of your application and the type of data you are working with. It's worth noting that there is a lot of overlap between SQL and NoSQL databases, and many modern databases support features from both categories. In order to be able to work with MongoDB database or the MongoDB server, all we need to do is just to download it and install it on our local machine. Then we need a UI tool to access and visualize data within our MongoDB server. So to do that, we have several UI tools or several tools, like for example, as we can see here, we have the Robo3T. We can also use MongoDB Compass, or also we have the Studio 3T for MongoDB. Also, there is a tool which I like because it's easy to use. It's called Mongo Express, and also we will use it within Docker. So to set up our environment, there is no need to install or download anything. All we need to do is to have Docker installed and running in our machines. In order to set up our working environment, we will be using Docker for that. We will not download and install MongoDB or Mongo Express on our machines and so on and so forth, but we will be using Docker instead. So let me briefly give you or tell you what is Docker. So Docker is a tool that is used to simplify the process of developing, testing, and deploying applications by using containers. So containers are a way to package and isolate an application and its dependencies in a single unit, which can then be running on any machine that has Docker installed, regardless of the host operating system or configuration. So this means we will set up our environment or our working environment using Docker. So later on, when you want to clone the code or make it run on your machine, all you need to have is having Docker installed and running. So this is it, why we need Docker. Now we will move on. As a next step, we will prepare our Docker Compose file where we will configure all we need to run this application. So we will need to set up MongoDB and Mongo Express for the UI. Now what we need to do is to write our Docker Compose file, and for this we don't need any IDE or we don't need any specific tool to write our Docker Compose file. All you need to do, or all you need to have first, is a text editor. Here for this case I will be using Sublime Text. You can use Notepad or any text editor you have. And also you need something else, is following me carefully and listening carefully to what I'm gonna tell you here. So within Docker Compose, I will not go so much into the details because I will prepare a full course about Docker. So you can find it on aliboucoding platform. But for now, I will try just to make things running. So the first thing we need to do, just go ahead and save this empty file that you just created and save it wherever you want to. And for me, in this case, I will save it into my desktop, and I will call it Docker Compose.yaml. Okay, so as you can see here, the name is Docker Compose. I made a typo, let me fix it. It's Docker Compose.yaml, and then save it. So this is just for me, for Sublime Text, to give me some colors when writing. Okay. Okay, so here I will type services as the first keyword, because within the Docker Compose file, we can define multiple services that will work all together. So the first one, we want our MongoDB. So here, this is a name. like you can choose the name that you want. So MongoDB, and now we want to pull the image, like which image we want to use for this service. So in our case, we want to use Mongo, and then let's give this container a name. So we can use the property container name, and I will call it Mongo_DB. Next, here we will define the ports or the mapping. This means on which port we want to use our MongoDB server. So here within the ports, we can provide a list of ports. So here, just in this new line, you type the dash and then space. And by default, the MongoDB is running over the 27017 port. So we will just keep using that one. If you have this port already in use, you can change it. All right, now we want our MongoDB container or MongoDB server to be persistent. This means that I don't want to lose the data every time I restart my container. So I need to create a volume for that. So here I will create a volumes, and here I will specify only one. Okay, but before that I will just go ahead and define a container. So just in a new line right here, and within the same level as services, define volumes, and here you can, for example, call it Mongo and just empty brackets. So here means that we want to define some volumes, and now we will map them. Okay, so here means that we will take the default value from our machines. Or you can also specify the full path where you want to store your data. Okay, so here let's go back to this Mongo. Here we will define it as Mongo, and we will map it to / data. So this Mongo refers to this one. So here you need to be careful. If you use, for example, Mongo123, here it should be also Mongo123. Okay, all right. Then after specifying or precising the volumes, I want to pass some environment variables. So I will use the keyword environment, and here, as you can see, image, container name, port, volume, and so on and so forth, all of them are on the same level. And to go from this to this, we use the tab. Okay, all right. So now I will go back to the environment, and here the first one, it's called Mongo_init DB or init database _root_user_name. And this environment variable is to define the username of my Mongo server. So I will just give it alibou as username. Then I will use the second one. I'll just go ahead, copy this. And the second one is init DB or init database root password instead of username. So here I just defined the environment variables for the MongoDB image or the MongoDB container, and here it will be alibou as a username and alibou also as password. So that's it for MongoDB. Now I will go ahead and go back to the same level, as you can see here, the same level as MongoDB, and I will define my second service, which will be the Mongo Express. Okay, so just give it a name. I will call it, for my case, Mongo Express. Of course, as we did before, we need first of all the image, and the image is Mongo, it's called like that, Mongo Express. So here, if you do not precise a version, it will be by default the latest one. It's this one, like with or without this, it's the same. So it will pull the latest image. All right, so let's give this our container a name. I will call it Mongo Express. just like that to be consistent. Also, next we need to map the ports. So by default, the Mongo Express runs on the port 8081. So I will keep it 8081. I don't want to change. And then I want also to provide some environment variables. So the first one is Mongo Express _ config _ MongoDB _ admin username. In one word, it's admin username equals alibou. So because here we have this username and so on and so forth, so I would just copy this one, paste it, and instead of admin username, it will be admin password. So it will be also alibou. And the last one, it's MongoDB server. So this one is MongoDB. So for this MongoDB server, this means which server, or what is the server IP address or the server name that I want to connect to, or where I have my MongoDB server running on. So this one is the same as this name. So if you change this name, you need to change it also here. So you need to be careful within this step. Okay. All right. So that's it. Let me save. And now let's go ahead and test and try to make things running and make sure that everything is working fine. Let's go now and make our Docker Compose file up and running. So go to your terminal or your command line tool that you are using and navigate to the destination where you saved your Docker Compose file. So in my case, it's in my laptop, and as I mentioned before, I saved it to my desktop. And we can make sure using the ls command to list what you have in that directory. So I have this folder, and I also have this Docker Compose file. Also, we can check the content, and as you can see, this is what we already did together. Okay. All right. So now to run this Docker Compose file, it's easy peasy. All you need to do is to run the command docker compose up. Okay. So docker compose up, spaces between, and then hit the enter button. So what will happen right now? Automatically, it will start pulling the MongoDB image and the Mongo Express image from the GitHub, from the Docker Hub, and then it will link them using all the configuration we did together and make it running. So it will be done in a few seconds. And then to make sure, or to test and check if our configuration works fine, we will try to access our Mongo Express UI, and we'll see if it's accessible or reachable or not. All right. So now, as you can see, just let me go scroll a bit up right here. So this one is created. The container Mongo Express is also created. And now what it's doing, it's attaching to MongoDB and Mongo Express. And here we see all the logs we have. And now if I open my browser and try to navigate to the address localhost 8081, we will see, or we will try to reach the Mongo Express interface. Now, if you access this address localhost 8081, you will have this UI, or you will have this web page, which is the Mongo Express. Let me zoom in a bit. So which is the Mongo Express, and here we have the databases. So these are default databases, and here, for example, we can create a new database. We can check what we have inside. Like, for example, we can click on view in here, and it will display all the collections that we have. For example, we have this one, which is just a delete me. We will delete it later on. And here we will have all the collections related or that belongs to this Alibou database. Okay, so now our environment is up and running. Let's move on and go more deeper within our course. We need first to understand the difference between MongoDB or SQL databases or S2SQL structure and NoSQL structure. So in MongoDB, a collection is a container of group of document which is similar to the table in an SQL database with some important difference. So this collection, the one is in green, is the equivalent of the SQL table within SQL database. A collection is a table within SQL database. Now, a document is a MongoDB JSON object that represents a record in the database. It is similar to a row in an SQL table, as you can see here. So collection is composed of a list of JSON data that we call document, and this document is the equivalent of a row within an SQL table, but always with flexible or dynamic schema, which means that the structure of the data can change over time. In contrast, a row with in an SQL table has a fixed schema with a defined set of columns and data types. One key difference between a Mongo collection and an SQL table is the data model. In MongoDB, collections store documents which are JSON-like objects with a dynamic schema. This means that the structure of the data in here can change over time, and you do not need to specify the structure of your data in advance. And the opposite side, SQL tables use a structured tabular data model where data is organized into rows and columns with a fixed schema. I will give you another difference, which is the way data is queried. In MongoDB, we can use Mongo query language, which is MQL, to query the data in collections. MQL is based on JavaScript and always allows you to specify search queries using a variety of operators and functions. In SQL, we use the structured query language, which is the SQL language, to query data in a table. So SQL is a standard query language that is used to define and manipulate data in database. So I want to remind you that it's worth noting that there is a lot of overlap between MongoDB collections and SQL tables, and many modern databases support features from both categories. Let's create a new Spring Boot project. So my preferred way, and the way I recommend, is going to start.spring.io, which is the Spring initializer, and create a new project from there. So let's go through the details. First of all, we want to use a Maven project. So feel free to use Gradle for Groovy and Kotlin. We will be also using Java as programming language. And of course, we will be using the latest version of Spring Boot, which is the Spring Boot 3. And at the time of recording this course, it's 3.01. So we will go ahead and use this. Now let's fill our project metadata. So here for the group, I will call it aliboucoding. And here I will just call it MongoDB or MongoDemo. Okay, I will give it MongoDemo like that as a name. I will separate it with a dash, and here it is the demo project for Spring Boot 3.0 with MongoDB. All right, so this is gonna be the final package name. We can change it, or you can change it if you want to, but it's totally fine for me. It's com.aliboucoding.mongodemo. All right, so we will use also the jar packaging and the Java 17 at least to run, and this is the minimum required version that you can use with the Spring 3.0. All right, now let's move on and add some dependencies. So the first one, we want to create a web application, so we will need the Spring Web. Next, we will need the MongoDB. So here, go ahead and select the Spring Data MongoDB. For the people who are not used to the MongoDB, or this is the first time that they learn the MongoDB, within the SQL databases, we are used to select the Spring Data JPA. So this one is the equivalent, okay? For this one is the equivalent for MongoDB database. And of course, we need to use Lombok to reduce the boilerplate code. For Lombok, you can also check my my course about how to use, or like the best way to use this Lombok tool. All right, so after Lombok, what we need to do, we have the web, Mongo, Lombok, and that's it. This is what we need for this project. Okay, so let's first explore quickly the structure of this project. So here we see that we have the parent, which is Spring Boot framework, and it's the parent is Spring Boot starter parent with the version 3.01. And then we have the information, or the metadata that we just precised within the Java property for the Java version. And here we have the MongoDB, the also Spring Boot starter web, and the Lombok dependency that we want to use. So that's it. Just go ahead and click on download, and let's open our project. Let's first have a look on our project. So I'm using IntelliJ IDE, and I already opened the project in here. So also this is the new UI from the IntelliJ. I hope you like it. I do. So yeah, let's go quickly through the structure of our project. So as you can see here, we have our pom.xml file that we already explained in the previous section. So now let's go quickly to the src file. We have here the main folder that contains all the Java resources with this MongoDB, or this Mongo demo application. And here we have our resources folder, and within the resources we have this application properties, but I like and I recommend using YAML structure because it's more readable and easy to use. So in order to transform this application properties file to a YAML file, so you have two options, whether you can delete it or you can just rename it. Okay, so let's go ahead and rename this one. And also as a hint, you can see this green banner down here. So this one, every time I use a shortcut, so you can see it. So for this one, it's a rename. Let me do it again. So for this one is a rename, and it's via Shift F6, and you can also see the shortcut for Windows and Linux users. Okay, so let's make this one a YAML file. So just remove the properties and replace it with YAML, and then click on refactor. So now our application is using the YAML representation. Okay, so this is it. I hope everything is clear. If not, go ahead, drop me a message and I will answer for you. Otherwise, let's move on to the next part. Now, in order to have everything within the same place and make it easy to run the application and so on and so forth, I would recommend moving the Docker Compose file that we already created from the folder or destination folder to the application files, or the application source files. So it's easy peasy. Just select this Docker Compose YAML and drag it or copy paste it to the to the root folder, and in this case it's the Mongo demo, and here just click on refactor, and to be sure that you copied it to the correct place, it should be within the same level, within the help, within the pom.xml file, and so on and so forth. So now if you already have your Docker Compose up and running using the terminal, so just go ahead and hit the Ctrl+C command to stop it from running. So you should see this message like container Mongo Express stopped and MongoDB also stopped. Okay, now you can close your terminal and we can go back to our IntelliJ. All right, so here let's open this Docker Compose YAML file, and there are two ways to run it, whether you can also use the terminal from here or you can use directly IntelliJ. And you see where we have the services. In here we have this icon or this double green triangle or this green play icon. Just go ahead and click on it to run the Docker Compose. So if you face this issue, saying that MongoDB cannot create container for service MongoDB and so on and so forth, because this MongoDB is already in use by another container, just go ahead and open your Docker dashboard like this, and within the containers you can just stop everything. And here, for example, this is our desktop, the one I just stopped. You can delete both of them and rerun everything and everything will be good. You can also go ahead and delete the images. For example, in here we have this Mongo image and we have the Mongo Express image in here. So I will just delete them and start from scratch. So the Mongo Express, this one is in use. Let's stop this container or delete this one. Yeah. And now we can go back to this image and we can delete this Mongo Express image. Okay, so now we are starting or restarting from scratch, and we go back to our IntelliJ and click the start. So it will start pulling everything once again. So here it's not that beautiful to see like in the terminal, but we already saw how it works. So yeah, it's also within the same it works the same way. So now we are also pulling the Mongo Express. Now we are starting, so creating MongoDB and Mongo Express, and we can see here that we have both of them up and running. Okay, so that's it, and let's move on to the next part. After having everything up and running and we have our project created, our MongoDB running on Docker, we have also our Mongo Express running that we can access our databases and see the data, the collections, and so on and so forth. Let me explain to you or give you some information about the architecture of the application or the demo application that we will create. So as you can see here, we can have several types of clients, and it might be a mobile application, Postman, or a web application. And these clients, they will send HTTP requests to our application or to our Spring container. And as you can see here, like Spring is running on the Apache Tomcat, the embedded one, and then the Tomcat will, and the Spring container, generally speaking, will dispatch the request to the desired controller or to the destination controller. So the request, it will come to this level, to this controller, and from here we will call the service layer, and this service layer will do some transformation process and validation process, and then we will go back to the service layer. So here we have some treatment, we have validation, transformation, and so on and so forth. So this is already the service layer, and this is where we implement all the business logic of our application. Well, not the application, but for this controller, for example. Okay, once everything is transformed and we have our object validated and so on and so forth, what we need to do, we need to call or to do a call to our Spring data in here, which will handle the persistence of our documents. Okay, so and here to use the Spring data will use a model or a document to communicate with a database which is running on a Docker image or a Docker container. Okay, so and then like when we want, for example, to save or create a new object or new document within our collection in the database, in the MongoDB database, we will be using this model right here, send it to the MongoDB, persist it or save it, and then we will get the response, and the response will be sent back to the service layer and all the way back to the controller, and then finally it will go back to the customer, okay, or the application client. So what we see in here, like this green container represents the Spring Boot container, and the one inside is like the process that will be running inside the Spring container. So this is mainly our demo application architecture. Let's move on and start implementing these small pieces one by one. If you have any questions, don't hesitate to contact me, or if everything is fine, just move on. And so as we mentioned, our application will communicate within a MongoDB database. So let's go ahead and connect and configure our application to be able to communicate within the MongoDB database. Right, to do so, just go to the resources and open the application YAML file. And here it's like we do with the Spring Data JPA, or if we want to connect to a SQL database, we need to provide all the information and properties within the application YAML file. So to do so, or to connect our application to MongoDB, all we need to do is to provide a bunch of information to tell Spring or to tell the MongoDB starter what to use as properties and information to connect. Okay, so let's go ahead and do it. So the first one, it will be spring.data.mongodb.username. Okay, so now you can see if that it's automatically transformed to a YAML representation. But as I mentioned, YAML, so from this space from Spring to data, it's a tab. So it like the indentation might be slightly different from one configuration to another, but this is a tab. Here are 2 tabs, and here we have 3 tabs, and as you can see, these white lines right here. Okay, so for the username, it's the one that we specified in here. So it's Alibou, so you need to make sure that it's the correct one and you don't make typos. We need also the password to connect, which is also Alibou, and then we need the host. So the host, the application is running locally, so our host is just localhost. Also, we need to precise the port, which is as defined in here, 27017. So 27017. And then we need to precise or to tell which database we want to use. Okay, no, not authentication database. This one we will come back to it later, but here it's just database. And the database, I will just call it aliboucoding. Okay, we will create it just later. All right, and here we have this authentication database. And here I will call it admin, or we will give it the admin name, and we will see in the next part, we will explain these 2 parts, and especially this authentication database. So within this configuration, now we will be able to connect to our MongoDB server, and we will be able later on to use this aliboucoding database. Okay, but let's first go ahead and explain this, why we precise or why we gave this admin database as authentication database. Let's first go ahead and create this aliboucoding database. To do so, I'll just copy the name in order to avoid typos. And to do so, just go to the Mongo Express UI and then follow the following steps. In here, we see the list of the databases. And here we have these 3 databases that we will explain in a few moments. And in order to create a new database, just here type or paste the database name and just go ahead and click Create Database. And as you can see, now we have this aliboucoding database created. So if you click on View, we see here that by default we have this delete me collection, which we will delete later on. Or we can, for example, see the other collections once we have them, or we can view them, export them to JSON, import also some data, and so on and so forth. So we can, or we have multiple operations that we can perform within this database and its collections. So let me go back here. So just to conclude, we created our database and now we see it within this list. Let's move on and let me explain these 3 tables right here. When we were configuring and connecting our application to MongoDB server, we specified this authentication database and we gave it the name admin. So let's understand what is this authentication database property and what is the admin database within MongoDB. As you can see in here, we have this admin, we have the config and the local. So I will just delete this database for the present moment and I will create it later on just to focus only on these 3 databases. So first we see that we have this admin database. So in MongoDB, the admin database is a special database that contains administrative information and operations. It is used to store the system collections such as the system.users and the system.versions. As we can see here, we have these 2 collections, which contain information about user account and the version of MongoDB that is running. Okay, so let's have a look in here. So we have the version 6.0 and we have the authentication schema and so forth. Let's go back to this system users or the view of our admin database. So the admin database is not intended for general use and is not intended to store application data. Instead, it is used to perform administrative tasks such as creating and modifying user accounts, authenticating users, and managing the database system. So if we have a look in here on this system users, we see that we have, for the moment, we have only one line or one record of data. And here, okay, so here it's not a document, but it's a collection, and within, as we mentioned before, within the collection we have the document. So now let's use the correct words. So here we have this document which has the ID admin.alibou, and this one is for the user alibou that we mentioned when we first created the configuration, or when we first set up the configuration of our Docker Compose file. So let me explain it, or let me go back in here and let's see here. This is what we provided. So the MongoDB init database root username. So the root username is alibou and the root password is also alibou. So if you change this one to a different username, you will see it exactly in this system.users collection. So here is the user and the database is admin. We have also the list of the credentials, and we have also the roles for this user. So the role is root, because when we created the configuration was the root username, and the database is the database admin. So if we create a new one or a new user within the database or within this collection, we will have it within the same structure. Okay. So also it's worth noting that the admin database is not the only special database in MongoDB. So there are also several databases, including the local database, which is used to store local data, and the config database, which is used to store or used as a shared cluster to store metadata about the cluster. So here, if we check what we have here, so we have the startup logs, and when we start up our application, we will see all the logs within this local database. And also if we check the config, here we have the system sessions, and for the moment we don't have anything because, as we mentioned, it's a database used in shared cluster to store the metadata about the cluster itself. So that's it about these three databases. Don't forget to bring back, if you deleted the database, don't forget to recreate it. So I will just recreate it, and now we can move on. Let's now create our first collection and documents. So to be able to correctly understand that, so a document, as we mentioned before, a collection is a set of documents, okay, which represents a table and a set of rows within an SQL database. But now to do this within Java or within our Spring Boot application, so this will be our document, which will be product, for example, and within this product we will create the equivalent for it, which will be the product.java class. And this product will have many fields, like field 1, 2, and 3, and each field will have a specific type. Okay, so let's go to IntelliJ and try to create our product.java class. So now within our main package, I will just go ahead, right click and create Java class, and I will create first a package. I will call it product dot, and here I will just give it a product.java. Okay, so this product.java, I will create a bunch or few fields. So I will have an ID. I want to have an ID for my product, and I also want to have a name and also a string description, for example. Just 3 fields for this product.java. Now let's use some Lombok annotations to generate code and reduce the boilerplate code for our application. So we will need the data annotation, always from the package Lombok, and this data will generate getters and setters, equals and hash code, and also a required args constructor with all the fields containing final keywords. So for example, for this private final, if we make this one final, it will be part of the default constructor, all the constructor that will be generated by this data annotation. Okay, so if you want to know more about the Lombok annotations, how to use them, how they work, just go ahead and check my platform, check my YouTube channel to get the full tutorial about that. All right, let's continue. We will also need the all args constructor, and I will tell you just now why we need it. We need it because we want also to use this builder annotation. So this builder will create a builder for our product class, and the builder is already also a design pattern. It's a design pattern called builder. So also you can check my YouTube channel and the aliboucoding platform to know and learn more about this. All right, so this is our class, Java class. Now let's move on and make this one a document or a collection that we can use within our application. Now we want to transform this product.java class to a document or to a collection that will work within our MongoDB. So let me put this in in full screen. So to do so, like we used to do within SQL databases and Spring Data JPA, we use the entity annotation, but for MongoDB collections and documents, we need to use a document annotation. Okay, so this document annotation is from org.springframework.data.mongodb.core.mapping. Okay, so let's import this, and before, let's go ahead and have a look. But before that, you see that now we have this MongoDB icon, and this will tell that this object or this class right here now is a MongoDB document. Okay, and now also we see that we have this icon, so open in database view and so on and so forth. So this will represent the ID of our document. But before that, let's go ahead and check quickly what is this annotation. So the annotation, it identifies a domain object to be persisted to MongoDB. So every time you create an object or a Java class and give it the document annotation, it will be identified as a domain object, and it will be persisted to MongoDB, of course, when we use it. So when we work with documents, it's important to specify and precise the ID. So we chose that our ID will be of type string, so we can use integer, we can use longs, and so on and so forth. It's up to you what type you want to use. And here we need to add this ID annotation, always from the same package, Spring Framework Data Annotations. Okay, so yep, that's it. Now we transformed our product.java to a document that can work within MongoDB. So as a next step, we will try to persist some data and see what will happen within our database. Like with any type of databases within a Spring application, to be able to communicate with a database, we need to create a data access layer, or we need to create a data access object that will be able to communicate within our database. So to do so, we will create here a new class, but in this time, we will use an interface. Okay, so we will create a repository. I will call it product repository. Hit enter, and all we need to do as a first step is to extend the Mongo repository. We need to extend the Mongo repository. And also, as you know from the Spring Data JPA, the Mongo repository, this interface is a generic one, so I need to pass two parameters. The first one is the entity or the document. Now we talk about documents, we don't talk about entities anymore. So here we talk about our product, and also we need to pass the ID as parameter, or the type of the ID. So in our case, it's a string. Okay, so let me bring this into a new line so you can see it better. So yeah, now our Mongo repository or product repository is extending this Mongo repository, which is here, it's Mongo specific Spring Framework Data Repository interface that will allow us to use so many predefined methods like inserting, saving, find all, and so on and so forth. And also this Mongo repository is extending the list, paging and sorting repository, query by example executor, and so on and so forth. So we can see all this in details in a further course. All right, so now we have our repository. Now we can use this repository to communicate or to interact within our database. Now we have our document, we have our repository. Let's try to start our application and see what will happen within our database. So the application started, and now I will just go, as you can see here. So the application started on the port 8080 and it started in 1.7 seconds. So now I want to go to our Mongo Express and refresh this aliboucoding database and see what did Spring do. So Spring did not create the table, so don't panic, because it will create only, like, it's a lazy creation, so it will create it will create the collection only when we persist at least one data, only when we try to persist some data into this collection. So at that time it will be created. So let's go ahead and do it. So to do so in an easy way, like, you don't need to create a controller to expose it, use Postman and so on and so forth, but we can do it in a much simpler way. So we will go to this Mongo demo application. It's where we have the Spring Boot application annotation, and here we will create, or we'll try to inject a bean. So I will use the bean annotation, and here I will use the public command line runner. Okay, so this command line runner, I will just call it command line runner, and in here I will specify some parameters, and I will just explain it in a second. And I will use a lambda expression for that. Okay, so within this command line runner, this means that I want to execute some code at the application startup. So when I start my application, and if Spring finds that we have this command line runner bean within the configuration, it will run everything that we have inside here. And also within this command line runner, we can inject some dependencies. For example, I want to use my product repository, so all I need to do is to inject it right here. Okay, so let's call it a repository, and now we will be able to have our repository injected within this command line runner, and also I can use it in here. Okay, so first of all, let's create a var product equals product dot builder dot build. Okay, so we will use the builder annotation that we already added within our product class, and here I will just give it a name. So the product, let's call it iPhone, for example, and a description, I will give it a simple description, for example, smartphone. Okay, just to make it easy. All right, so here I did not precise the ID because it will be auto-generated. I just need to specify or to precise the other fields that I need. And now all I need to do is my repository dot, and here we have so many methods like equal, find all, hash code, and so on and so forth. And among these methods, we have a method called insert, where we can insert whether one entity or a list of entities. Okay, so here I want to insert my product object, or the product that I just created in here. Let's go ahead, restart the application, and check the changes within our database. So now the application is restarting, and yeah, now it's ready. Let's go to Mongo Express. I will just refresh the page right here, and boom, we see that we have product. First of all, let's go and delete this delete me collection. We don't need it. So just type here delete me, and then click the delete button. So here we have our product collection. I will just click and see what we have inside. So inside here we have our ID, which is of type string, because we chose, or we decided that we want it to be a string. We have the name, description, and we have this class. So I will just click to see the representation. So the ID is of type object ID. So this is automatically handled by MongoDB. And we have the name, which we chose, and also we have the description. Also, we have extra information, which is the class, and here it contains the full package or the full path of our document or of our Java object. Okay, so this is a first test, and now let's move on and perform a bit more operations within our MongoDB database. Let's try to create a CRUD operations within MongoDB. So if we go back to our architecture or API architecture, we see that we already implemented this part right here, which is the Spring data that can or has a role to communicate and persist data or manage all the database transactions using this API model. And this one is the product repository. Okay, now we want to implement this service layer. So here we want to create a bunch of methods that will use this Spring data or this repository to communicate within the database. For example, I want to create a method to save a document or to save a product to the MongoDB, read all or find all, find by ID, delete, and so on and so forth. Okay, so let's move on and implement this. Now we will create a product service that will hold several operations that we want to use. Then, so I will just go ahead, create a class, and I will call it product service. Okay, so within this product service, I will create a few methods which they will represent the CRUD operations, such as save, find by ID, find all, and delete. Okay, so the first one, it will be public string save, and this one will take as a parameter an object product. I will just call it product, and for the moment I will just return null, and we will implement it later on. The next method is a public product, and this one is find by ID, and in here I want to pass my string product ID, or just call it ID, it's up to you. And also I will just return null in here. We will implement them later on one by one. So next one, it will be the find all. So I will need to return a list from Java utils package, a list of product, and then let's call it find all. It takes no parameters. Let's return null for the moment. And the final one, it will be a public void delete, and this delete will take a string as ID. So we want to delete a product by its ID. Okay, so this one is a void, so we don't need to return anything. Now let's go ahead and implement this one by one. The first thing we need to do before implementing this is we need to give this service the service annotation, so it will be picked up by the Spring framework and become a Spring Bean. We also need, or we want to use, the required args constructor from Lombok, and this required args constructor, it will create a constructor with all the final fields within this class. So for example, here I want to create a constructor within this product repository, use this annotation and create a private final field. So if I create another one, it will be also included within the auto-generated or the generated constructor by this annotation. Okay, so now I have everything set up for my service. I can just move on and start implementing the different methods. Now we'll focus on implementing the functionalities or the logic for this save methods. So here, just as a reminder, normally we should use data transfer objects or representations to communicate or to persist data and communicate with our API, but this is just a crash course and a demo, so I will be using directly our document. So here we have the save. Just this is going to be for you as a reminder. I will make a to-do here, use a DTO and also validate the objects. Okay, so this is just for you as a reminder. I will make this one also a to-do. All right, so now in order to persist the data or save a document to a collection, what we need to do is, using the repository that we have a list of functions. So we have the save and we have the insert. So inserting, it will always create and insert a new document into our collection. And here there is a prerequisite with that, which is that the object or the product that we want to pass should have a null ID. So it will auto generate or generate a new ID and persist a new document to the collection. If we decide to use the save method, so the save method will play the role of creating and also updating this document. So in case, for example, I want to update a document, all I need is to precise the new fields or the new values of the fields, and also I need to precise the ID of this entity or of this document, and it will be automatically updated into the database. And if I pass a product object that does not contain the ID, or if the ID is null or the ID does not exist within the collection, it will be creating a new one. Okay, so let's use the save method in here, and I will pass only the product. So here it says that this is error because we want to return a string, and here's easy peasy. All we need to do is get ID, and that's it. This is the implementation of the save method. Now let's implement this find by ID method. For this find by ID, we will always use our repository, and then we have a method called find by ID, and all we need to do is pass this ID. Okay, but here this find by ID, as you can see, so let me make this one full screen so you can see the auto completion. So this find by ID method will return an optional of product, so that's why it's in red. And here what we can do is, for example, we can do or else and return a null object or an empty one, or throw an exception. It's up to you what you want to do in here. So this is it. This is the find by ID method implementation. Now to implement the find all, it's the same thing. We will need our repository dot find all method, and this find all, it will automatically return a list of product. So yeah, this is the find all method. Now let's move on and implement the delete. Deleting a document is also a piece of cake, so we need to use our repository dot delete by ID, and all we need is to pass this ID as parameter. And what will happen when we call this delete by ID is, if the document exists, we will delete it, otherwise nothing will be done. Okay, so that's it within this delete method. So far we have all the pieces of our API architecture. So just a reminder, we set up the MongoDB, we have the repository, we also created a document, and we just finished implementing the service layer with different methods. Now we need to implement the controller. So let's go ahead and implement our product controller, which will hold all the API endpoints that will receive the HTTP requests from our clients. Now let's create our controller to expose the API and also to make calls to the services that we just implemented. So on the product package, right click, as always, new class, and let's call it product controller. So now to make this product controller a REST controller or Spring controller, we need first to add the REST controller annotation. We need also to give it a request mapping, and here let's give it /API/v1 products, and also we will use the Lombok annotation, the required args constructor, and this in order to automatically inject the following dependencies. So let's declare our private final product service. Let's call it service. Okay, so now our product is ready, and now we still need only to implement the CRUD methods, save, find by ID, find all, and delete. The first method that we will implement is the post mapping, and it will be public response entity of type product. Let me make this full screen. So it will be a response entity of type string, and this method will be the save method, and we will need a request body, and this request body will be of type product. Let's call it product. And here all we need to do is return response entity dot okay, or created, whatever you want. And now we want to make a call to our service dot save method. Okay, the one that takes a product as a parameter and then just a semicolon right here. So let me explain this one. So here we have the post mapping, so we will be able to access this endpoint or this method using post request, and accessing it by using /API/v1/products, and we need to pass a product object as parameters. Okay, and then it will make a call to this service.save, and then it will return a response entity.ok, and this will be compatible with this response entity because our save method already returns a string. After the save method, let's implement the next one, which will be a get mapping, and this one will hold or will make call to the find all. Okay, so it will be a response entity of a list of product, and then let's call it find all, and we don't need any parameters. Let's import the list in here, and like we did just in here, if we want, we can go ahead and copy this one, paste it in here, and instead just call the find all method without any parameters. Okay, so this is the get mapping or the get method that will allow us get all the products from the database. Let's create the third method, which is also a get mapping, and this time we need a path variable which will hold the product ID, and let's call it public response entity of type product because we want to search a product, find by ID. Okay, and now we need to add this annotation path variable which will help us map this variable that we will create right here within the one that we will get as parameter. Okay, so product ID, it should be the same name as here. This name should be the same as the one we used in the get mapping annotation. So this one is also a string product ID. Okay, next, it's also easy and it will be the same as this one, so I will just copy paste it, and this instead we will call the find by ID method, and we will pass the product ID as parameter. So that's it about this get mapping or this find by ID method. Let's move on and implement the final one. Now we will implement the final method that we have. It will be a delete mapping, and for this one also we will ask to have the product ID as a path variable. So we want to remove or delete a product by its ID, and then it will be a public response entity, but this time it will be of type void, because we know that the delete method won't remove anything. And let's call it delete. And here also we need the same thing like in here. We need a path variable with the same name, product ID. And now all we need to do is to call our method. Okay, so it will be here return response entity dot accepted dot build. Okay, but before that we need to call our service dot delete, and here we need to pass the product ID as parameter. Okay, so this means that first we will delete the product from the database, and then we will return that the operation or the request was accepted. So that's it about the CRUD operations. Now let's move on and make some tests. Let's start our application and make some tests. Let's try some endpoints, try saving a product, getting a product from a database, and so on and so forth. So the application is up and running. I also will go and check the database using the Mongo Express. Here, if you refresh the page, we see that we have our product. Now it's initialized, and this one is from this bean, the command line runner. So within the MongoDB demo application, we created this command line runner bean. So we want to comment it out. So at startup, it will not create any more records. Okay, so you can leave it for now. We don't need to restart the application. Let's now jump and go back and check here. So as we mentioned, we have this line right here. So just delete it because we don't need it for now. We want to test it using a postman. Now just go ahead and start your postman, and in here click on this plus button, and you will have the possibility or the UI to create a new or to perform a new HTTP request. So our request it will be a post, and the address is this one. So this one is 8080. So it's localhost 8080/API/v1/products, and it's a post request. And within the post request, as we saw, that we need to pass a body. Okay, so the body will be of type raw, and here select JSON as type. So within here, we can also go back to our IntelliJ, open our product document. So here we have the ID, we have name and description. And as we mentioned, we only need the name and description. So just go ahead, copy these two properties, go back to Postman, and just paste it. Okay, so this one will be the name, comma, description, colon, and the value here. So the name, I will just call it Alibou, and the description, test from Postman. Okay, so now when I click on this send button, I expect to see as a result the string ID of the newly created document within our MongoDB database. So let's go ahead, click on send. So this is what we see right here. And also, if you go ahead and open the Mongo Express, refresh in here, we will see that we have the line get inserted into our collection. Okay, so this is the one. Let me perform another operation or another save. I will call this one, for example, Samsung, and as a value Galaxy S21. I don't know which version it is right now. Click send. So we see also that we have a different string. Let's go back here and also click on this back button, refresh, and we see that we have now the new the new line in here. Okay, so this is good. Let's try to copy this ID, and I will duplicate this one, duplicate tab. Now I want to perform a get method, so no body in here because we don't have a body with the get. And here it will be /API/products. If I click on send, it should retrieve all the products from the database, and this is what we see right here. So we have the ID, the name, and the description, and we see the 2 products that we just created. Now I want also to query, and if I do / in here and I pass the ID as a path variable and I click send, I'm expecting also to get this object right here. All right, so so far the save is working, find all and find by ID are also working fine. I want to try and fetch let's try to perform a delete. I will create a dummy record in here so we can delete it, and I will click on send. So this is the ID, I'm gonna copy it, and here I will go back and click send again to make sure that we have this dummy record returned back. All right, so I will duplicate this tab too, and here instead of a get request it will be a delete request. Okay, and we know for the delete we need to pass the ID as a path variable. So click on send, and here you see that we have a 202 accepted, and if I try to perform a select all, I should see only 2 records in here. Okay, the same if I try to do the same and refresh the page using Mongo Express. Okay, so now we have our API working. Let's try move on and make or create and do something much more interesting. Let's try to see how really MongoDB works and how we can really use this performance using Spring Boot 3.0. As we mentioned before, a NoSQL database or a document is a non-structured object, so we can have multiple values, or like the schema may evaluate through the time. So this is what we will be doing right now. So this is what we will implement at this phase. So I will close these 2 objects, and here I will just add a new field. I will create a list of strings, and they will represent some labels. Okay, labels, or let's call them tags. I think tags is better. So now I want to have a list of tags within each product that I want to create. So I will just restart my application and go ahead and try to persist a new product within this tags list. Okay, let's go back to our Mongo Express, make sure that we still have everything, and now we can open our Postman, go back to this post request, and here I will add a comma and the object that I want to insert called tags, and these tags is a list or an array of string. Okay, so this is gonna be tag 1. Well, I will just not call it dummy, I will just call it smartphone here. So this will be tag 1 and tag 2. Okay, so let's send this. So we see that we have our new ID, and if I open back this, we see that we have now a name, description, this is the class, and we have the tags. Let me open it, and you see here that this is how it looks like. So it looks exactly the same. If we take this one, it looks exactly the same like the object we passed as parameter to our backend. Okay, so in this way, we can extend our document. Now let's try to extend it with a bit more complex object, like creating a class and associated or make this product composed of that one. At this phase, I want to extend the properties of the product document and add a new field which I wanted to be of type class. For example, I want my product to be part of some category. Okay, I want to categorize my products. So what we do usually here is private category, and we just call it category right here. So we don't have the class. So let's create a new one, create a class category, but I want to create it within the package category. And as I mentioned, always, every time I use a shortcut, you have it down here within IntelliJ. Okay, so hit OK. We see here that we have category and we have it right here. So this one will be just a simple class. And I will copy these three annotations from Lombok, paste them right here, and I will just create few fields. So it will be private string name, so category name, and private string description, for example. Let's make it. Our object category will have a name and a description. All right, so I will go back in here, make sure that we have this object category. And now I will restart the application and let's see how this will be represented. So I restarted the application and now I'm back to Postman. And here I also added this field, category of name. So for this case, I will just pass the name of the category. I won't pass the description. It's just a choice. And let's hit the send button and see what will happen. So we have always our object created. We have this 200 from the backend. Let's open now our Mongo Express and see what we have in here. So let's click on the product collection. And now we see that we have the smartphone Galaxy S21 with the tags that we already created. And here we have this object right here with value names. So I'm going to click on this one. And here, here how it looks like. So we have all the previous information, and now we have the category with the value name phones. Okay, I want to go back to Postman and add description, just to show you that how it's gonna behave exactly. This is what I want to show you. Some cat description. Okay. Just to show you what will happen. And this one, we had a typo already, smartphone test, and Galaxy, let's make it 210. All right, let's give it only one tag just to see the difference in the data. Now click on the send button. We have our ID and the response is also 200. I will go back here, click on the back button, and then I need to refresh the page. Okay, so here we see this is the new record or the new document that we just inserted with the Galaxy 210. We have the tags, category, phone, and description. So what I wanted to show you in here is that if we have an object, so here we passed a Java class or a Java object, and once we passed without category, without description, and the second one is with description. So we see that the category, it adapts based on what we want to persist. So this is what means it's a non-structured data. Okay. Now, what if we want to link the product document or the product collection with the category collection? This means what? This means every time I want to create a product with a category object, I want this category to exist somewhere within the category collection. Okay, so for example, if I would try to insert a new product into our collection, I need to make sure that the category exists, and I don't want to do this programmatically. Means I don't want to query manually the database and ensure that the product ID exists and so on and so forth, but I want it to be done automatically. So I want to see exceptions, like to make it easy, I want to see exceptions when I try to persist a product with an unknown category ID from our database. All right, so let's move on and try to implement this option. Let's now transform this category.java class to a document. So to do so, first we need to have a private string or integer or long ID. I want to give it an ID. And then we need, of course, this document annotation on the class level. So category now is a document, and now we see that we have this Mongo icon and this key the key icon. Now let's make it ID. Our category will be now a collection within our MongoDB database, and we already have it in here within the product collection. So let's try to restart the application and let's try to persist some data to be able to interact with the category collection. Let's, as usual, go ahead and create a repository for that. Okay, so let's create an interface. Let's call it category repository. Just rename this. And as we did before, let's extend the Mongo repository. Okay, and here we need to pass the generic types, which is category and the string for the ID. So now we have our category repository ready to use. Let's move on and try to persist some categories or some initial data at the application startup so we can use them. Because we don't have yet our category controller and we want to move on within testing, and this is something that we do not require for the present moment, I will just go ahead within this Mongo demo application and I will bring back this bean, this command line runner bean. Now I will also inject the category repository and I will try to inject some data. Okay, I will just call it also category repository. This one I don't need it, so I'll just comment it out. And in the beginning, I will create a var category equals category.builder.build. Okay, so .builder and then .build. And here I will just give a name. So I will call it category 1, and here maybe a description, and then category 2, and I will just create 2 of them. Description here I will just rename it to category 1, and I will create a second object, call it category 2, and it will have the name category 2 and description also category 2. All right, now I will just call the category repository and tell it to insert the category object and category at the same time. So now like this, when the application starts, we will have 2 categories already inserted into our database, so we can easily use them. Our application is restarted now, so let's go and check that we have our category collection in here, and if I open it or I click on view, I'm expecting to see these two lines. Okay, so now what we have these categories inserted into our collection, and we have the IDs, so this is good. So one thing I want to do before we move ahead and start testing, let's comment out this bean annotation so we don't create these two categories every time we restart the application. So this is not a behavior that we want to have. Now I want to go to Postman, and let me describe the scenario. So when we have, now let's try to link it to SQL databases. So within SQL databases, when I try to create an object, for example, I want to create a new category, and I pass a category that does not exist within the database, I should get a null pointer exception, or I should get an exception telling that this category with this specific ID does not exist into our database. Okay, so here, in order to do that, like generally speaking now, in order to do that, all we need to do is to specify the ID that we have in our database. So for example, if I pass this ID right here, I expect that the new product that I will insert using this category ID should be also referenced into in the database. Okay, but if I specify a different ID, for example, if I do this, if I specify a different ID, like here a dummy ID, so this should not work, and I have to see, or I need to see an exception in our database. So let's try to send this request and see if we are able to insert this new product or not. Okay, so I'm just gonna rename it right here, test, and also for this one test, just to be able to identify it quickly. So go ahead and click on the send button. Now we see that we have a 200, so this means not okay for us. Okay, so the request is 200, okay, but for us it's not okay. Why? Because if I go back here and open the product category, I can see here for the last element that I created, we have this element category, or we have everything, and even we see right here it's underscore ID, which is not referencing the category collection that we created. Okay, so in order to fix that, let's go ahead and move on, and I will show you how to link two documents. So let's try now to link product to category. Okay, so to do that, we know in SQL databases, or when we work with Spring Data JPA, we use the one-to-one, one-to-many, and many-to-many. But when we work with NoSQL databases, we use different annotations. Okay, and one of them is we work with an annotation called dbref. Let's first have a look on this annotation. All right, so it's an annotation that indicates the annotated field is to be stored using com.mongodb.ref. So this is just to say it's a reference. This is a reference to another document or to another collection. Okay, so when we want to try to insert a product with a category that does not exist into our collection, this will throw an exception and it will not be accepted on our application level. Okay, so let's go back to Postman and try to test this again. Okay, so I will use the same dummy ID, and here I will just call it test2 just to make sure that we have everything up and running. Okay, make sure you start your application and then go back and test right here. Now I will try to insert a category without the ID field. Okay, so this one, it's going to be a dummy name, for example, as a value, and I will go ahead and click on the send button. So, and this is what we are expecting. Okay, so we have an exception in our backend. Let's go ahead and check it. So we see right here that we have this exception cannot create a reference to an object with a null ID. Why? Because here when we try to insert this category, we don't have, or we did not precise an ID for this category. So when MongoDB will try to make the link between these two documents or between these two collections, it will not find any link between them. So it will not find any category with a null or a null ID. All right. So that's it for this part. So but now, okay, let's go back and make some more tests. So if I go back to this category and take or pick up this ID right here and use it. So this is the ID. Let me remove the name, and then we click again on the send button. So we see here that we have this 200 OK. Let's go back and refresh our collection. Let me go back here, open the product, refresh the page, and scroll down. All right. So we see here that we have this test2 with this tag and so on and so forth. And here we have that it's referencing to the category, and we have this ID right here. So if we open this one and see, so we see that this category is a DB-ref or a database reference, and it's referencing to this using this ID right here. In this part, I want to show you how you can integrate OpenApi, or what we know as Swagger UI, within an application or Spring Boot application using MongoDB. Right, so first of all, we need to add a dependency right here. So let's go ahead, open the pom.xml file, scroll down here after Lombok, or let's do it just after the Spring Boot starter web, and here just create or add a new dependency tag. Okay, and the artifact ID is the Spring Doc OpenAPI Web MVC UI. So this one right here, and the group ID is the org.springdoc, and make sure you are using the version 2.0.2. So here I want to highlight something, and that if you want to use the OpenAPI UI or the Spring Doc OpenAPI UI, the version 1.6 point something, this will not work with the Spring Boot 3.0. So make sure you use this one, the version 2.0.2 of the artifact ID Spring Doc OpenAPI Starter Web MVC UI. Okay, once you add the dependency, just go ahead and click on this button to load the Maven project or the Maven changes, or you can just do right click here and go to Maven and then reload project. So now our application is up to date and all the changes has been reloaded. Let's go ahead, restart the application and test. After restarting the application, go ahead, open the browser and open a new tab and navigate to localhost :8080, which is the port that you are using for your application, and then /swaggerui/index.html, or if you type this swaggerui.html, it will be automatically redirecting you to this swagger-ui/index.html. All right, so here we see our API definition or API documentation and what we know as the Swagger UI. So here we see that we have this product controller because it's the only controller we have right now within our application, and we see the different endpoints. Okay, so let's go and try a few things. So if we try to get all the products and I click on execute, we see right here we have, or we get the same result. So we have the ID, the tags, which is null, for example, for the first ones, and then we have some tags. And for the latest ones, we have the category that we already linked. So we have this ID, and automatically it fetches the name and the description. Okay, so this is, for example, for the get. We can also create a new product from here. And if you click on this try it out button, here we have the ID, but we don't need to specify it. Let's leave this as string tag also as string, but the ID right here and the name and the description, let's try to get the ID of the category 2 or the cat 2. So I'm gonna just copy this one and put it in here. I will also remove this because I don't need them. I need only the ID. And then I will just click on the execute button and see what will happen. So here we see that we have the curl if you want to use it. And now we see the response body. So I will just copy this ID so we can use it for the next endpoint. So if I go back here just to make sure that we have everything and execute it again to get all the products. So if I scroll down, I see that the new product that we just created with the name string, description string, and so on and so forth, and we assigned it, or we assigned it to a category with this ID. So here we see that it automatically fetches the category, the name and description, and which is cat2 and cat2. Okay, so let's go and try the get by ID. So here, and click on try it out right here, paste the product ID and click on execute. So when we click on execute, we get this one. So this is the information we persisted. So I will copy this one. I will copy this object, and now I will try to update it. Okay, so we said, if you remember, we said that the save method that we implemented in here within the product service, this save method, it will update or create a product. Okay, so I will go back to my Swagger UI, and then I will go to the post, and here I will just paste this one. Okay, so for the name, I will call this one Alibou, so just to check that we have it correctly, and then Alibou, and for the ID and category I will leave it. I will also make it Alibou tag, for example. Okay, now if I click on execute, I expect that my product will be updated and not creating a new one. So let's check it from here. So if I open category, and I will also refresh the page, and if I scroll down, I see that I have Alibou, and I will try to search if I have any other product with this string as name and description. So we don't have it, and now we make sure, or we know 100% that this save method will do both creating and updating a product or a collection. Okay, all right, so I just wanted you to be sure about what we already implemented, so feel free to play more with it. Now I will just go back here and pick a random ID. So for example, I will pick this one. I will try also to delete it. Okay, so let's try this delete endpoint, try it out, paste the product ID in here and click on execute. Okay, so we have this 202 and this one means accepted. Now if I refresh, so I no longer have that product within our collection. Okay, so this is mainly it. I will let you have the time to play with this Swagger UI, and don't worry, every time you add an endpoint or every time you create a new controller, it will automatically be shown right here. So all you need to do is to add the dependency, make sure you add the correct one with the correct version, the one which is compatible with the Spring version that you are using. For this one we are using Spring 3, so make sure you use the correct one.
Perfect. So you made it to the end. The course is fully available on my platform. Just go ahead, create your account or log in if you already have an account. Enjoy the course, and also don't forget to subscribe to my channel and smash the like button so you can keep me motivated to continue on producing content like this for you guys. Thanks a lot and see you next time.